This episode of the Pumps and Systems podcast is brought to you by Sepco, fluid sealing solutions for every application.
Think about your car. You have bearings in the axles of your car, right? So those tires, they're rolling on bearings. If those bearings fail, the car is not going to run. If that car is not going to run, there's going to be maintenance and downtime with that car. It's the same thing with rotating equipment, just at a much larger scale, because an entire plant or factory is running on that piece of rotating equipment.
Hello and welcome to the Pumps and Systems podcast. I am your host, Tom Baer, a managing editor at Pumps and Systems magazine. Today we're going to be speaking with Zach Nepa, regional manager at Sepco, about bearing isolators, what they are, what applications they can be used in, and the benefits of using them. So without any further ado, let's get into the episode. All right, so I will start by welcoming you. So welcome to the Pumps and Systems podcast. We really appreciate you taking time out of your schedule to be here with us. So how are you doing today?
Thank you for having me. I'm doing great today. Ready to get going.
That's awesome. Glad to hear it. So today you're going to be talking to us about bearing isolators. But before we get into that, would you mind introducing yourself? So tell us about who you are, where you work, what you do, anything you think that our listeners and viewers might want to know.
My name is Zach Nepa. I am a regional manager for Sepco, which is Sealing Equipment Products Company based out of Alabama. And I cover the East Coast region, if you will, from Maine to Virginia. Do a lot of work with bearing isolators and have had a lot of experience with successes in the field on those.
Let's get into our main topic. So would you start us off with the absolute basics of what are bearing isolators?
As they're stated, they isolate bearings in rotating equipment in manufacturing facilities. And this covers a wide array of facilities, but what they do is they isolate bearings from contaminations in the environment, which can lead to premature bearing failure, which leads to a bevy of problems down the road. They also isolate oil and keep lubrication clean inside the bearing, and they keep it present in the bearing as well by retaining it and preventing it from leaking out. So they're a non-contact seal, and they have a number of benefits that we'll get into in this podcast.
So are they replacing some existing technology?
Yes. Oftentimes you'll see lip seals in rotating equipment sealing the bearings, and lip seals are common from your own kitchen blender. You'll see a lip seal. They're common on cars, but they're a contact item. They're typically made of some sort of elastomer. And what they do, the problem with lip seals is that they wear the shaft over time where they're mounted. And shaft wear is going to allow contamination ingress, and it's going to allow lubrication to leak out as well. Whereas a bearing isolator does not contact on the shaft the way that a lip seal does, and it doesn't create frictional wear. And so lip seals are very common. There's also even older styles of, we'll call them labyrinth seals, and they're essentially a series of ridges that are supposed to slow down contamination, but they can easily become overwhelmed. These could be either cast into the housing, or they could be in the form of LER rings in pillow block bearings, for example. There's a number of different types of contacting seals, and anything that's contacting is going to wear over time. So that's what bearing isolators seek to replace.
So can you tell us a little more about what kind of differentiates bearing isolators from those existing technologies?
First and foremost, bearing isolators are non-contact seals. So they're a two-piece design where there's a rotor and a stator, and the rotor and stator never come in contact. And the rotor stator interface is what does a lot of the sealing, but the rotor itself externally does a lot of sealing as well through the use of centrifugal force. So the shaft will turn the rotor, and from there it will expel most of the contamination that would normally work its way into a bearing housing. And then should any contamination get into the bearing isolator itself, which is very rare and hard to do, it has an interface with the stator that allows for it to expel the contamination internally as well. With a bearing isolator, you can stand there with a hose spraying onto the bearing isolator, the bearing housing, and the bearing isolator will expel the water and keep it from getting into the bearing housing. And this applies to the field in that most bearings are supporting some other piece of equipment that's moving either fluids or powders. It's moving some sort of material. And that material has a tendency to leak out of the stuffing box and get into the bearing housing. That's where bearing isolators come in and differentiate themselves in that being non-contact, they are able to keep the contamination out without wearing the bearing housing or the shaft.
All right. So then what applications are there for bearing isolators in the field?
There's quite a few. There's pumps are probably the most common, but we've gotten very creative with it and gone into a number of other applications. So pillow block bearings, which you often see supporting mixing equipment, agitators, pulpers, those types of equipment. Paper machine rolls are another one. Really, any type of rotating equipment is going to have bearings. So, like a paper machine roll. And are you familiar with a paper machine in the paper mill?
Not intimately familiar,
It's
but
it's
I
a
know
it's
that they
a
are a thing that
large
exist.
conveyor of rolls that are all supported by bearings, and it's really the heart of the paper machine. It's where the paper is actually finished and made, and they tend to get a ton of contamination, whether it's steam or water coming off the roll into the bearings. And if one of those goes down, it kind of short circuits the entire system, and a bearing isolator can be applied to that application as well and significantly increase the life of the bearing on the rolls there. And for those of you watching on video, I have a bearing isolator in my hand and I can demonstrate fairly easily how it works. You have the stator right here. This is a stationary part, and then a rotor right here, which is a rotational part. The shaft actually drives the rotor by these O-rings, and it's in a non-contact way. It's touching the shaft, but it's being driven by the shaft, so there's no frictional wear. And what happens is as the shaft turns, the rotor turns with the shaft, the stator remains stationary. They're both named very aptly. One's rotating and one is stationary. And should any contamination leak in from the environment, what happens is the contamination would be mostly expelled away by the centrifugal force off this rotor. And should anything get in, what happens is it loses energy as it goes through the seal itself, through this tight interface, and then gets collected in this chamber and is actually drained out at this 6 o'clock position through a small weep hole. And then as far as actually keeping oil in, there's an oil return groove internally. Hope we can all see that here. This oil return groove would actually collect oil and return it to the sump where it belongs. So that leads to, contamination not getting into the bearing itself, and it also maintains the oil levels within the bearing. So you can maintain lubrication without having to have oilers replace lubrication frequently.
So then can you tell us a little more about how bearing isolators can be applied to various different applications?
Yes, yes. So there is a number of mounting designs. This one that I have in my hand is actually a press fit, and it would press into a bore of the bearing housing. You can actually bolt them on, so there would be a flange on the out on the stator, and you can actually bolt them onto a bearing housing for certain applications such as pillow blocks, which require a groove fit. We can actually have a groove built onto the stator that rolls right into the bearing housing. And then, say for gearboxes, for example, that's a very diverse set of applications and housing styles. A gearbox, for example, could be pressed in, it could be flange mounted on, and gearboxes run into a number of different problems. Some of them have high oil levels, in which case we actually have a contact seal which uses a lip seal, but it's very important to distinguish that the lip seal is not contacting the equipment. It's actually housed within the bearing isolator itself on a very smooth sleeve that's incorporated into the bearing isolator to make it last much longer. Essentially, what we're doing is we're putting a puzzle together. So a bearing housing is going to exist as the OEM has sold that piece of equipment or as it's been modified in the field. And what we strive to do is apply bearings to bearing isolators, excuse me, to bearing housings without having to modify their equipment. Now, there are some occasions in which case you would have to modify the equipment, but we try to be as minimally invasive as possible as far as that goes. But to answer your question more broadly, bearing isolators can be applied to most bearing applications. There are small, I guess we'll call them throwaway type bearings out there that are meant to be replaced often, we would probably shy away from those just because bearing isolator can't be applied to them.
This episode of the Pumps and Systems podcast is brought to you by Sepco. Sepco has been a leading provider of quality products and exceptional service for over 40 years, but we're more than just a provider, we're your partner. Our products range from mechanical seals to compression packing, graphite items, and gasketing materials. Additionally, we offer specialized items like die-formed packing rings, molded PTFE parts, thermal management solutions, and fiberglass products. Find your sealing solution today at sepco.com. So, what are some of the benefits of using bearing isolators?
There's a number of benefits. First and foremost, your bearing is going to last a lot longer. With the increased bearing life, you're going to have increased equipment life. It's going to eliminate downtime and maintenance as far as that piece of rotating equipment goes. Just think about your car. You have bearings in the axles of your car, right? So those tires, they're rolling on bearings. If those bearings fail, the car is not going to run. If that car is not going to run, there's going to be maintenance and downtime with that car. It's the same thing with rotating equipment, just at a much larger scale, because an entire plant or factory is running on that piece of rotating equipment. Everything's connected. And if one cog in the system fails, then the rest of there's a chain reaction. So a bearing isolator can make a piece of equipment last much, much longer. It's going to eliminate the need for constant oiling, which is oil is very expensive, especially if you're, going through it on a, weekly, monthly basis. It can get very expensive. And it essentially allows you, this isn't a direct benefit, but if one piece of equipment is lasting longer, it allows you to focus on other things and not become overwhelmed in a plant. So there's a downstream effect of saving a few pieces of equipment and making them last longer by being able to, reallocate your focus to other problems that could be solved and not have a constant headache that you're going back to. So there's a number of benefits to having bearing isolators, and they're really not expensive relative to the cost of what those problems can lead to down the road.
So, do you have any real life stories or examples that you can share with us about bearing isolators in the world, or any further information you want to share with us?
Yes, a number of them. I mean, there's a number of success stories out there. Many of them are probably published in Pumps and Systems, actually. One that I would like to point out, and I'm going to bring another product into this because it worked as a system, but we had a pulper and a paper mill that had a gearbox underneath it, right? The gearbox was facing contamination from the pulper itself, which is essentially just a giant blender mixing up paper. And it's a vertical application. And right below it is a gearbox with a bearing housing that was facing contamination and from the pulper itself. And it was barricaded by cement. So to replace that bearing would mean that they'd have to knock down that cement wall that's barricading it, get a crane in there and pull it out. It's a minimum $100,000 job if you have a bearing failure on that. So we did a combination of products on there. One was an air seal on the stuffing box itself to limit the contamination, but in a paper mill, there's still contamination everywhere from other adjacent equipment, and just the environment is very humid and there's paper stock everywhere. I don't know if you've been in a paper mill, but it can sometimes look like a winter wonderland of paper stock everywhere, just white fluff everywhere. That bearing was overloaded with contamination, and they were constantly changing oil and, not daily having to change that, gearbox out, but it was a yearly job when that gets very expensive, just the job itself and then the downtime that's related to it. So we put a bearing isolator on the bearing housing, and we were running actually a cost savings analysis on the air seal. The air seal, did a great job on the stuffing box, and an oiler came by and told us, "Hey, I haven't put new oil in that gearbox in months, and I had been doing this on a almost daily basis for years, and now that bearing is just free of contamination. So seems like a very simple thing to do, a very easy fix really to, solve major headaches. So that's one application. Another would be paper machine rolls. We've done a number of these on paper machine rolls where if a bearing fails on a paper machine, they would have to train out a roll. I'm going to go to a household analogy, but picture a giant rolling pin that's conveying paper on a belt, and there could be upwards of 50, 60 to 100 of these on one machine, and if one fails, it has a domino effect, and you have to shut the machine down. And we applied bearing isolators to the bearing housings of these paper machine rolls, and the ones that we've applied them to run for, it's a non-contact seal, so they run for the life of the equipment, really keeping contamination out the whole time. And there's just a number of these pumps on a regular basis, stock pumps in the field. If it was improperly sealed at the stuffing box, the product, whatever the pump is pumping, tends to work its way into the bearings, and we apply them to those, and the bearings, last much longer. And there are pumps in the field that the whole plant relies upon to run, and eliminating those problems is where the bearing isolator comes in.
So it seems like one of those situations where it's something pretty small that has a pretty big impact.
Yes, it's almost like a baby aspirin can save you from a heart attack. It's that simple. I don't want to say easy fix. Nothing's an easy fix, but you can extend the life of bearings significantly by applying a bearing isolator. And you're also saving on oil. You're also, you're going to have that ripple effect that I talked about throughout the plant, where you can, not have to focus on a piece of equipment because there's constant bearing failure. But yeah, I could go on all day about the number of applications we saved. We actually just did one in a paper mill on a side entry agitator. It was a horizontal shaft, and they were failing bearings constantly, and we put bearing isolators on those, and they've been running ever since. And they had constant like monthly failures of bearings. And it's also important to note that there is all the downstream effects, but just the bearing itself, those bearings themselves are not inexpensive. And, to make those last longer, you're going to lead to significant cost savings as well.
All right. So then before we wrap up, are there any final thoughts you'd like to share, or any advice you want to leave our listeners and viewers with?
So in short, bearing isolators are a non-contact seal that's relatively inexpensive to the cost of the problems that it solves. And they're very easily applied to a number of bearings in the field, and they can truly save your facility tremendously on costs, downtime, maintenance. Overall, it's a non-contact seal designed to last the life of the equipment. And I thank you all for your time today.
Thank you for your time today, and we really appreciate you taking the time to talk with us.
Thank you for having me.
Huge thanks to Zach Nepa for joining us today and teaching us all about bearing isolators. And big thanks also to Sepco for sponsoring this episode. If you're listening to the podcast and would like to watch it, feel free to head over to our YouTube channel to watch the full video version. That's going to do it for today. Thank you so much for listening or watching, and we will see you next time.